This is a workshop that we put on every year on the IU Bloomington campus to basically have the students learn about robotics and about programming.
They're given a robot that we built ahead of time, and the robot has a number of sensors on it, and it has grabbers at the front.
The robots we use are the Mindstorm NXT robots. We have an infrared beacon located in a small arena. Below the infrared beacon is a ball, and the task is to not only detect the signal, but to move towards the signal so that it can grab the ball.
So they have to program the robot to find where is the signal at all, because they might not even be facing it when they start. And then they have to find a way to move towards that signal and then hopefully pick up the ball and then do some kind of celebratory dance.
The workshop is targeted for high school students and middle school students. We don't assume a technology background.
We have a pretty wide array of people who come to the workshop. There's definitely some ringers who come in who've had experience with the actual robot that we use in the camp, and then other kids who just are interested in the idea of robots, but they've never actually used them before.
We give them a brief introduction on the robot and the value of programming and the methodology, and then we break into teams of about 3 to 4 students per team.
I'd say the biggest thing that we can do to help the kids solve the task is actually try to pry them away from the robot and the computer and try to think through what they're actually trying to accomplish. So we like to use a whiteboard and pen, really low tech, and just try to think through what are you actually trying to do and break that down into the smallest individual steps that we can, so then we can turn around and tell the robot to do that.
It's supposed to find walls and turn to avoid them, and now it's just avoiding everything.
The robots will basically only do very precisely what you're telling them to do. If you tell this robot to move to, say, open its arms to be able to grab the ball, unless you tell it specifically to when to release the motor or when to stop doing that, the motors will sit there and continue to move in that manner. We try not to give the students the answer on how to solve the task. What we do is we try to lead them through the process.
They had to really step back several times and try to think of, yes, we need to accomplish this large task, but we need to break it up into very small components and solve each of those problems individually. I think also, since we try to throw in little tidbits about how it relates to our daily job, they maybe will consider a career path that they hadn't considered before.
Everyone seemed to be having fun. Everyone was relaxed, but really engaged in the task at hand.
I think the camp was fun for the students, definitely, for a lot of reasons. A lot of them really latched on to the idea of troubleshooting and the mix of frustration and excitement that goes along with trying to solve a problem.
It's hard.
And you're having challenges with it?
We're getting it done.
You're getting it done?
Sort of, we think.
It's going well.
Towards the end, the students get to do one run of their best program. We put the robot in the cave, they have 2 minutes, and everybody's right there.
Whose robot in the program can execute the task the fastest and in the best way. That really gets the students going. We'll often have students literally jumping up and down, rooting for their robot to figure out what's going on. So it's quite entertaining for everybody involved.
I thought it was really cool, even though our robot sort of failed at the end. It was still really neat to be able to build it and, have it programmed the way that we wanted to and put in the commands on the computer and then see it happen. And I've never done anything like that before, and I thought it was really, really neat.